Okay, hello everyone. You are welcome to this video. In this video, I'm going to be solving objective questions of 2020 past questions. Okay, so I want you to give me your attention. The first one says, which of the following substance is an example of a fine chemical? Okay, a fine chemical means chemicals that are produced in very little quantity. They are highly pure, very pure, and they have some applications as against heavy chemicals that are produced in very large quantity. So the answer here is ethylene. Okay, the second one says the IUPAC name of the compound represented by the structure below is, from what I can see here, even though this is not complete, but if this is carbon, that means you have 1, 2, 3, 4, 5. Okay, that is pent. Okay, since we don't have pent in the options, that means this should be a mistake, meaning that here should be hydrogen, right? I want to be sure, yeah, and here should be hydrogen. This is a mistake, so this should be 1, 2, 3, 4. 4 means buta 1, 3 diene, because the double bond is in position 1, 1, 2, and position 3. You see that? Then the chloro is in position 2, so that will be 2 chloro. Okay, 1, 3 butadiene. So 2 chloro, 1, 3 butadiene. The answer is D, right? Makes sense. The next one says, which of the following substance is a polypeptide? Okay, a polypeptide. So the only substance that has peptide chain is proteins. Protein is the only substance there that has a peptide chain. Very important. Okay, the next one says, which of the following products could be formed during incomplete combustion of a hydrocarbon? Okay, it's usually carbon dioxide and water. Okay, but there are cases where carbon oxide can be formed, and there are also cases where hydrogen can be formed, especially when the burning is in limited supply of air, right? So in this case now we can go ahead and choose these two. That means I and I, which is D. But generally, okay, incomplete. Okay, it's even written here incomplete. For complete combustion is CO2 plus water. But incomplete combustion, yeah, CO. It's actually supposed to be CO and water, but sometimes it can just be hydrogen. That's beautiful. Okay, so the next question says, what quantity of electrons is lost when 1 mole of ion 2 ion is oxidized to ion 3 ion? Of course, from the word ion 2 and ion 3, you know that only 1 mole of electron is lost. And this is the equation. You get ion 3 plus just 1 electron to balance up. Minus 1 plus 3 is 2, which is the same thing as here. Now the next one says, what is the mass of silver deposited when 24.125 coulomb of electricity is passed through a solution of silver? Well, according to Faraday's law, we can say mass over molar mass is equal to the quantity of electricity over NF. The mass in this case is what we are looking for. The molar mass of silver is 108, equal to the quantity of electricity here is 24,125. Then divided by N means the number of electrons, which is 1. Silver is plus 1, Ag plus. So this is 1 times 96500. So that means your M now is going to be 108 times 24,125 divided by 96500. Okay, so I think I will have to get my calculator here. So permit me to use a calculator. Okay. So we have give me a moment, my calculator is coming on. We have 108 times 24,125 divided by 96,500. That's giving me 27. So this is 27 grams, which is exactly A. Now the next one says equal masses of calcium triazocarbonate 4 were added to dilute hydrochloric acid at the temperature specified. Under which of the following conditions would the reaction be the slowest? Okay, now first of all, slowest, not fastest. So first of all, chips is slower than powder. Powder reacts faster. Okay, then lower temperature is slower than higher temperature. Higher temperature reacts faster. So the answer is D. Okay, quite an interesting question. Now this one says the high solubility of ethanol in water is due to hydrogen bonding. Hydrogen bonding is responsible for solubility. Hydrogen bonding is also responsible for high boiling point of ethanol. Now number 9, which of the following metals reacts slowly with cold water? Okay, all of them react with water. Okay, but the one that reacts slowly with cold water is of course silver. Silver is least reactive, right? Least reactive, okay? But since it says with cold water, I wouldn't say silver, because silver and iron react with steam. So that's not correct. The answer is calcium. Potassium and sodium react violently with cold water. But since it's cold water, calcium is the best answer. The other ones react with steam. Steam at red heat. Please note that. Okay, number 10, which of the following pairs of properties of alkaline metals decreases down the group? Okay, that decreases down the group. Let me see. Yeah, the answer is already A. A is correct. The reason B cannot be the answer because reactivity actually increases down the group. As you go down the group, they are more reactive than when you go up. Then for melting point, atomic radius increases down the group. Always, right? For metals, it increases. Atomic radius group, period 1 is 1, period 2, 2 shells, period 3, 3 shells, period 4, 4 shells. So you see, the size increases as you go down the group. Then ionization energy increases as you go reactivity increases as you go down the group. So the answer is first ionization energy and melting point. Okay, that's very important. Now the next one says the most suitable process of obtaining water from an aqueous solution of sugar is by, well, if you want to obtain water, the best way to do this is by crystallization. Yeah, you crystallize the sugar out. Filtration, you can't filter sugar. Sugar is soluble in water, so cannot be filtered. The same thing with decantation, that cannot be possible. Distillation is for two liquids. So now number 12 says group 7 elements in their combined states they are called halides. Now group 7 elements are called halogens generally, but in a combined state you call them halide. Just like you have sodium chloride, you see, that's a halide. Okay, so the next one here says when an ionic bond is broken, bonding electrons are, when an ionic bond is broken, bonding electrons are gained by the most electronegative atom, shared between participating atoms, gained by the most electropositive, lost by both participants. Of course, the answer is A. Okay, the electronegative atom is the one that will attract the bonding. Okay, then for this one, the oxidation state of chlorine in NaClO3 is, now it's easy. Sodium is 1, oxygen is -2 times 3, which is -6. So 1 minus 6 is -5. So that means chlorine is +5, which is D. Or you can just say sodium is 1 plus X, then -6 equal to 0. So X minus 5, because 1 minus 6 is -5, equal to 0. That means X is equal to 5. Very important, right? Then the next one says a balanced chemical equation is based on the law of conservation of mass. A straightforward question. Now, which of the following pairs of elements has the greatest difference in electronegativity? The answer is C. The reason is because sodium is constant here and fluorine is the most electronegative element, so has the highest electronegativity. So the greatest difference is in sodium and fluorine. Okay, so the next one says a factor that is considered most important when citing a chemical industry: availability of storage facility, nearness to industrial establishment, favorable climate. Nearness to raw material is a very important factor in citing a chemical industry. Okay, the next one says the boiling point of pentane is higher than that of propane because the answer is that its intermolecular force is stronger. And the reason for the intermolecular force being stronger is because pentane has a higher molecular mass. The higher the molecular mass, the higher the boiling point. Okay, except when hydrogen bonding is involved. Now the next one says, which of the following solid will not decompose on heating? The answer is calcium triazocarbonate. Carbonates of calcium and potassium do not decompose. Carbonates of calcium and potassium do not decompose. All others decomposes. Now, please note that this is a very important concern, right? Let me even write: ammonium chloride decomposed to give ammonia and hydrogen chloride. Lead nitrate decomposed to give lead oxide plus NO2 plus O2. Sodium hydrogen triazocarbonate decomposed to give carbonate CO3 plus water plus CO2. It's important you know these things. But the carbonate of sodium and potassium do not decompose. Now the next one says the following molecules have double covalent bonds between two atoms except between two atoms. The answer is water. Water does not. Oxygen is like this. This is the structure for oxygen with two lone pairs each. The structure for carbon dioxide is like this. This is how carbon dioxide is and has two bonds, double bonds. The structure for ethene is this. This is how ethene is written. You see, has a double bond. But it is only water that is done like this. OHH is just single bond. So the answer is water. I believe that makes sense. Now 21, the type of isomerism exhibited by cis and trans isomer, that is geometric isomerism, right? Number 22, which of the following compound has the lowest boiling point? The lowest boiling point. Now the answer is going to be C. The reason is that if you notice, both this one, and this one, all of them exhibit what we call hydrogen bonding. And any organic compound that exhibits hydrogen bonding must have higher boiling point than that do not. Now you may be asking, how do I know compounds that exhibit hydrogen bonding? Any compound where hydrogen is bonded to oxygen, or hydrogen is bonded to fluorine, or hydrogen bonded to nitrogen exhibit hydrogen bonding, and their boiling point is high, quite high. Okay. Now the next one says an alkanol containing 60% carbon by mass would have a molecular formula of, well, I think this is quite easy. To have 60% carbon by mass, and since it is an alkanol, you have CHO, and wow, nothing is said here. Well, I think since we are not given the percentages of each of them, they just told us the percentage of carbon, we cannot assume that of oxygen or that of hydrogen. So the best way to go about it is that in all of this, in which one is carbon 60%? Calculate the percentage in all of the options. This is the best way to go about this. Like here now, the carbon total is 36 because 12 times 3. Then divided by the whole is hydrogen is 7 plus 1, 8. Okay, C3 H7 means 12 times 3 plus, this is 1 times 7 plus 16 plus 1. This is 17 plus 7, 24. 24 plus 36. 24 plus 36 is 60. So this is over 60 times 100. Oh, it looks like we have our answer already, because 36 divided by 36 times 100 divided by 60 is 60 already. Yeah, so this here, carbon has 60%. I don't need to do for the others, but you can go ahead and do it, but this is correct. Now number 24 says, which of the following compound would release hydrogen when reacted with sodium metal? The only compound that will release hydrogen is ethanoic acid and ethanol. Both of them react with sodium. Like this one now, when it reacts with sodium, you will get CH3, COONA, then plus hydrogen gas will be released. The same thing with ethanol. When ethanol reacts with sodium, sodium will always displace the hydrogen. You will get sodium ethanoate like this. ONA, then plus hydrogen gas too will be released. This is very, very important. Okay, so the answer is I and II, which is D. Now the next one says, which of the following substance is not a reducing agent? Of course, take oxygen out. Oxygen is not a reducing agent. Oxygen itself is an oxidizing agent, but these other ones are very good reducing agents. Then number 26 says, which of the following statements is correct for a reaction at equilibrium? A, the rates of the forward and backward reactions are equal. That's the statement. There is no other. That's a correct statement. B says all reactions cease to occur. No. C says the reaction has gone to completion. No. D says the amount of product equals to amount. Oh, no. These are all lies. The correct answer is A, right? Then number 27 says, which of the following reactions are always exothermic? Combustion is always exothermic. Neutralization is always exothermic. Decomposition always need heat. So you always need heat to decompose something. So the answer is I and I. Very, very, very important question, right? Now the next one says, which of the following standard condition is not correct about energy changes? Standard temperature 298. This is correct. Delta H at 298 is the activation energy. I don't know about that. Standard pressure 1 atm. Concentration of solution must be 1 mole per dm cube. So the answer is B. This one is way outside what is correct. Then the number 29 says, if 5.0 cm cube of 0.2 mole per dm cube sodium carbonate. Give me a second, please. Okay, so if 5.0 cm cube of 0.2 mole per dm cube this is diluted to this solution, what will be the concentration of the resulting solution? Now, in the principle of dilution, we have a formula that M1V1 is equal to M2V2. So M1 is the initial concentration, which is 0.2. V1 is the initial volume, which is 5. Okay, M2 is the final concentration. That's what we are looking for. The final volume is 250 based on the question. It was diluted to this. So that means your M2 now is going to be 0.2 times 5 divided by 250. That will be 1 over 250. And of course, this will be 0.004 mole per dm cube. So C is the answer. You can see life is beautiful, right? Now look at number 30. The initial volume and pressure of a given mass of gas is V and 3P. That's the initial volume and pressure. What is the pressure if the volume is increased to 2V at constant temperature? Now, if you increase volume from V to 2V, that's double. That means this one will be reduced by 2. It's as simple as that. It's going to reduce as 2. So it's going to be 3P over 2, which is 3 over 2P, which is A. Now, another way you can achieve this, you can say P1V1 is equal to P2V2. So the initial pressure is 3P, initial volume is V, equal to final pressure. That's what we are looking for. Final volume is 2V. So if you want to find final pressure, it's going to be 3P times V divided by 2V. This will cancel this. I will still have 3 over 2P. As simple as that, right? Now the next one says the volume of oxygen at STP is required to burn completely 7.5 dm cube of methane according to the equation. What volume of oxygen at STP? So 7.5. Okay, this is easy. If you look at methane and oxygen, their mole ratio is 1:2, meaning that if this guy was 7.5, the volume of this guy is supposed to be 2 times 7.5, which is 15 dm cube. This is quite easy. We don't have a problem here now. So the answer is 15 dm cube. Okay, number 32 says when 250 cm cube of a saturated solution of copper sulfate at 30 degrees Celsius was evaporated to dryness, 5.0 grams of the salt was obtained. Right? What is the solubility of the salt at 30 degrees Celsius? Okay, the solubility, depending, is equal to mass over volume times, okay, I can actually say mass over molar mass multiplied by the volume over, or multiplied by 1000 over the volume in cm cube. Yeah, this would do. So the mass is 5.0 grams. The molar mass is, according to this, 160. Then multiplied by 1000 divided by the volume is 250. Okay, so this will cancel here 4 times. This will cancel here and make here 40. So the answer is 0.125. So which is D. The next one says the bond between ammonia and hydrogen ion in this is coordinate covalent, or what you call a dative bond. That is always between an ion, a positive ion, and an electron rich, compound. Quite easy. That's a dative bond. Okay. Now the next one says which of the following oxides has giant covalent structure? I want to say something here, going back here, is that covalent bond is always between two non-metals. Electrovalent bond is between a metal and a non-metal. But anytime you have an electron donating species and electron deficient ion, they form coordinate or dative bonding. Now number 34, which of the following oxide has a giant covalent structure? Among all of them, the one that has a giant covalent structure is silicon oxide. Yeah, because this one is ionic, this is ionic, this is covalent. So the covalent structure, giant covalent structure, is silicon oxide. Which of the following hydroxide is not readily soluble in water? All hydroxides are soluble in water. The only one that is not soluble is this calcium hydroxide. Of course, you should always know that all potassium salts or base, sodium or ammonium, all of them are soluble. When you see a compound that contains potassium, sodium and ammonium, just rest, it is soluble. Okay. Then the other one says which of the following statements about solubility of a salt is correct? A says a salt whose solubility increases with temperature would not crystallize easily on cooling. That's not true. It will crystallize. B says crystallization would be efficient in separating out a salt whose solubility increases considerably with temperature. This is correct. But let's see. C says a salt whose solubility is independent of temperature will not. No. D says solubility of a solid does not have. No. So the answer is B, right? So it is important you know this. Then number 37 says how many moles of H2SO4 are there in 50 cm cube of 0.108 mole per dm cube? The solution of the acid. Okay, we are looking for number of moles. Number of moles is actually equal to concentration times volume. Please never forget that. So the concentration is 0.108 times the volume is 50 divided by 1000. Now if the volume is in cm cube, you must divide by 1000 to convert it to dm cube. Okay, very important. So if I multiply 0.108 multiplied by 50, then divided by 1000 is giving me 0.0054, which means 5.4 times 10 to the power minus 3. Okay, so the answer is B. Quite easy, right? Now number 38 says if 20 cm cube of sodium hydroxide was neutralized by 20 cm cube of 0.01 mole per dm cube tetraoxosulfate 6 acid, What is the concentration of this solution? Oh, okay. Now we can simply use CaVa, this neutralization, over CbVb equal to Na over Nb, right? And don't forget that in this kind of question, you must write the balanced equation. When you have H2SO4 and sodium hydroxide, you need two of these to balance. The ratio is 1:2. So concentration of acid here is 0.01. Volume of acid is 20. Concentration of base is what we are looking for. Volume of base is also 20. Number of moles of acid over base is 1/2. So 20 cancels 20. Concentration of base, if you cross multiply, is 0.02. So that's the answer. The answer is D. You can see that life is beautiful here, right? Then number 39. Electrons always occupy the lowest empty energy level in a statement known as, that statement is the Aufbau principle. The fact that electron will always occupy lowest empty energy level. Okay, Aufbau principle is the one that made that statement. As a matter of fact, Pauli's exclusive principle says that no two electrons in an atom can have the same values of quantum numbers, can have the same energy. Hund's rule says that if you are filling a degenerate orbital, you must fill it fully. You must fill it half filled first before you now fill it. You now pair it. You must fill it singly first before you start pairing. But Aufbau principle is the one that has to do with you must fill lower energy first before you go ahead to fill the higher energy. Very important. Now number 40 says, which of the following metals do not react with water to produce hydrogen? That kind of metal should be a metal do not react with water to produce hydrogen. Okay, all of them react with water to produce hydrogen. The only person here, all of them actually react with water to produce hydrogen. Zinc does, sodium does. So the only one that may look odd, but I still don't think so, is lithium. Okay. Now the next one says, which of the following arrangements of elements is in decreasing order of electronegativity? Decreasing order. Okay, electronegativity increases across the period. Okay, so I should follow this. This is decreasing order. Phosphorus from phosphorus, silicon, aluminum, magnesium, sodium. Electronegativity decreases as you go across the period from left to right. That means if you go from right to left, it decreases. Yeah, very important. Of course, you can see that this is a group 5 element, group 4, group 3, group 2, group 1. It works like that. Now, number 42 says the metallic bond in magnesium is stronger than that in calcium because magnesium has, a greater number of valence electrons. No. Low melting point. No. The answer is simple. It is the smaller atomic size. Metallic bond, the smaller size, tend to be more attracted. Remember, metallic bond is the attraction between the nucleus of one atom, to the electrons of another atom. Okay, so that's very important. Now the next question says, consider the reaction represented by the following equation. Now this is the reaction, is a double displacement reaction. The steps that could be taken to obtain pure dry silver chloride from the mixture include. Now I want to say this. This is a double decomposition reaction. It is usually used to produce insoluble salts. Silver nitrate is a soluble salt. Sodium chloride is a soluble salt. Silver chloride is not a soluble salt. Sodium nitrate is a soluble salt. So you can see that this guy that is not soluble, the first thing to do is to filter it, right? You filter, then you wash, and you dry. Yeah, so A is the answer. Now the next one says, how many electrons does this contain? Now, the number of electrons is supposed to be equal to the number of protons, which is 15. It's supposed to be, but this is for a neutral atom. That means an atom that does not carry any charge. This is for a neutral atom. Okay, then now for the charge, plus minus 3 means it has gained 3 electrons. So that means the number of electrons, sorry, this is E. The number of electrons is now 15 plus 3. The 3 gained, which is 18. So the answer is C. Very important. Now the next question says, the atomic number of an element would be equal to its mass number if the atomic number of an element would be equal to its mass number if it does not contain any neutrons. Because don't forget that mass number minus atomic number, mass number minus atomic number is going to give us number of neutrons. Okay, so if they are equal, it means there is no neutrons. Now number 46 says, which of the following processes is not exhibited by atoms in order to attain a more stable configuration? The answer is hybridization. Okay, all of them. Losing electron is there, sharing is there, gaining is there, but not hybridization. So the answer to this question is D. Now number 47. Which of the following quantities is a molar quantity? A molar quantity is molarity, okay, or what you call molar concentration. Very important, right? Then the other one says the dilution factor is the number of times the volume of the concentrated solution is diluted to give the dilute solution. Yes. B says the amount of distilled water that is added to the concentration of solution. C says the quantity of distilled water added to 1 dm cube of concentrated solution to give dilute solution. Then YD says the act of diluting the concentration solution to obtain the dilute solution. Of course, D cannot be the answer, right? So the answer to this question is simply the number of times or the volume of the concentration solution is diluted to give the dilute solution. Right? That's very, very important. Or how much you diluted the solution. Now number 49. Calcium chloride is an ionic compound. Which of the following statements accounts for its ionic character? Okay, now first of all, it has a low ionization energy. It can easily give off electrons. Okay, yeah, and in the case of chlorine has a very high electron affinity. That means it releases energy whenever it gains electron. So these two, does the job, which is 2 and 3. Now, but we are also going to have 4 because chlorine also has a high ionization energy. Chlorine cannot give out electrons. It can only gain electrons. So this is also good to add. So the answer is 2, 3, and 4, which is this. Now number 50. An example of a biodegradable pollutant. A pollutant that is biodegradable, sewage. Sewage can be biodegradable. It will always decompose on its own. Okay, so this is the end of this paper. Thank you very much. See you in my next video.